outcome of some conversations we've been at the CU Boulder campus about the many assets that sit in a library, other museums across campus, and how to make them more accessible for teaching, for scholarship, and for outreach. And so we've asked some leaders in that field to join us to hear what they've been up to. And this is a collaboration between the Natural History Museum, the library, research computing, and the Center for Research Data and Digital Scholarship here at the CU campus. I want to thank Dean Robert McDonald, Dr. Shelley Knuth, and Dr. Thea Lindquist for their help and support of the series. I also want to thank Cindy Edgar and Suzanne Baylog for organizing and promoting the series. So it's three folks. We're starting off today. There is another speaker on the 31st of March and then the 28th of April. Those two, like this one, will require you to register, and the information that you use to register here, you can use to register for the two future talks. So it's my pleasure to introduce today's speaker to you, Dr. Larry Gall from Yale University. He got his undergraduate at Stanford, and that's through Stanford that he has a Colorado connection, since he worked with Paul Ehrlich and Ward Watt, two preeminent biologists at Stanford. And Ward used to go, maybe he still does go, to Rocky Mountain Biological Lab every summer, and Larry was able to accompany him there for some research projects. So he has a Colorado connection through Rumble. He got his degree at PhD at University of Connecticut, and then went and joined the staff at Yale, first through their computing center because he has great abilities in computer science, and then through the Peabody Museum at Yale, and being able to kind of mesh his interest in entomology and butterflies with computing sciences. And that's where he is now. He heads the museum technical group on computerization, both in the entomology division at the Peabody, but also for the campus. So he's been real integral in not only working with the collections across the whole museum at Peabody, but also working with colleagues at Yale across the campus to make available their collections in digital formats. So without further ado, let me turn the floor over to Larry and for his presentation, Damned If You Don't. Thanks, Larry.
Thanks, Pat. Can everyone see the screen?
Yes.
Looks good. Okay. So damned if you don't. Well, so this is a talk about the digital campus, and the digital campus is here. You are damned if you don't or haven't drunk that Kool-Aid already. And so that's where that title kind of comes in. But also, if you've drunk the Kool-Aid, you've probably heard of a literal DAM, Digital Asset Management System, if you have to add in the S there to be technically correct. And so what do you usually think when you hear about a digital asset management system? Well, first of all, you're damned if you do with a digital asset management system, or you don't. So that we should extend the title. But typically what you might think is that this is a tool for discovering and describing and archiving the assets that you have and managing the metadata that's involved around them. And then also promoting scholarship and search along those assets, and also providing for some serendipity in that search experience as well. So what I'm going to do is give you sort of a semi-technical talk today. It's focusing on the Peabody Museum and then more broadly at Yale. It's going to have a historical component to it. So without further ado, the Peabody, where I work currently, is a natural history museum founded in 1866. We have over 14 million specimens or so, and those are distributed amongst 10 different curatorial divisions. And so you see the ones that are in green are sort of neontological collections, botany, entomology, IZ, VZ. We have a pretty strong paleo collection. Those are the ones that are outlined in orange down at the bottom. But even though we're a natural history museum, we have some other things too. We have anthropology, mineralogy, meteoritics, and a history of science and technology department. So it's fairly diverse. The governance of the Peabody, we have a director, and there's a board of curators, and those are faculty members from their respective associated academic departments. This is not all of them, but this is a smattering of them. Physically, we're located in New Haven. This is our downtown campus. We have another one out at what's called West Campus in Orange, Connecticut, and there's 3 buildings involved in this complex. And the curators live appropriately in the various buildings in here. The anthropologists across the street from the main complex. So like many institutions, we are technically closed right now during the coronavirus, but we would have been closed anyways, because as soon as coronavirus came around, we were just about to start on a major overhaul of our physical plant. So we're planning on reopening in 2023 in a brand new building. And this is what it looks like now, big holes behind the building, digging up the walls, you name it. Even the iconic Great Hall with the Age of Reptiles mural up there is completely boxed up. There it is with the conservation grid around it. Offers some really good viewpoints, though. You can get close up to it. This is Armin Margan, one of our folks here, looking straight down the jaws of a dinosaur. And so it's going to be a little while until we come back up for air in 2023, but still the digital operations continue. So this is a brief snapshot of where we are right now. This shows the 10 curatorial departments along the left there and the counts of the items in there. And we catalog differently from one department to another. So you may be familiar with lot cataloging versus individual cataloging. If you're not, basically a lot, here's Dan Drew from invertebrate zoology, is that jar that he's got there. In that jar is probably 4 or 5 crabs, right? But he doesn't deal with each of the 4 crabs because they're in liquid there. He deals with the jar as the functional movable item. So when you account for that, instead of 14 million items, you have about 3 million, just shy of 3 million things that you could potentially database, okay? So it reduces the scope a little bit. And so where are we at? Well, this stoplight sort of themed thing shows us where we are after about 30 years of effort at the museum. We've got basically a metadata record available for just short of 70% of all the things that we think we have. And different departments are, of course, at different points in that process, depending on grant funding and staffing and all the usual things. So if you take a look at how that's gone from 1991 to the present day, the last 30 years, the black is the cumulative curve and the blue is the annual. So we're adding things at a general clip all along. I should say that we actually started exploring back in 1986. Some of you may remember this. This is an IBM AT. This is literally from the Cretaceous of computing. And so we started back then, but really we count from 1991, which is when we got our first collection management system for the old institution. This is Argus, which we had at the time. How many of you are old enough to remember a Gopher server? That was one of the very first things that we started patriating data to. That was before there were pictures on the web. Pictures came soon enough. We actually had a couple of large grants from the National Science Foundation and National Humanities to actually digitize. You couldn't just do it with a digital camera then. Eventually, the Global Biodiversity Information Facility came online in the early 2000s. We began patriating data to them. We went through a major restructuring. We changed our collection management system from Argus to EMU in 2004 to 2006, and we've been in it since then. This creature, the Yale Digital Commons, came along in about 2010. That's what I'll spend quite a bit of my talk on. And then, of course, after that, for the biologists amongst you, you're aware that iDigBio came on the scene. This is a national effort spearheaded by NSF to spearhead digitization of collections. And so iDigBio maintains a portal. There are now about 127 million specimen records and images, et cetera, in there that you can query. Here's a heat map showing where all those things are, in the portal. This is Peabody's records, about 1.7 million total in there, and it kind of follows the general trend that's there. But here's the problem. Literally, there's the problem. So the bioinformatics challenge here for natural history museums is that the US alone holds about 1 billion specimens, and the global figure is estimated to be about 3 billion, okay? So the Peabody's more than 14 million specimens. That's less than 0.1% of the global count. So this is a really serious, big challenge, a scale issue challenge. So this is a great article, Museums, the Endangered Dead. I recommend you read it if you want to see that. So the scale is really a challenge. And so that scale actually prompted the birth of the digital commons at Yale. So what is that? Well, metadata records are one thing, right? Those are basically specimen records, artifact records. They're textual for the most part. this is the one that really shows the trend. So this is the growth in the associated digital assets occurring over that same 30-year stretch. You can see what happens in 2010 is there's an inflection point. Suddenly, that growth rate takes off exponentially, and it's showing no sign of abating whatsoever. The 2020 and 2021 values are the results of a little bit of a COVID shakedown, slowdown, but it's just going like nuts. So what's happening, of course, is that the advent of inexpensive digital cameras and image processing is ubiquitous now. And so there's a wide variety of image types and other types being captured by natural history museums. We are just shy of 900,000 assets at the moment, so we probably will break 100 million next year. So it's quite a lot of stuff. And so this is basically the analogy. You know, this poor girl is sitting there with a fire hose trying to drink water. The water is coming in just as fast as you can deal with it. This is pretty much what's happening with digital assets around. So we thought, gosh, you know, this is happening to us. Is this really common? The answer is, of course, it was common. So the question is, what made us give a damn at Yale Peabody? Well, there were multiple Yale units at that same time. We were all simultaneously looking for asset storage, discoverability, delivery efficiency, scalability. And none of us could afford basically a digital asset management system singly at that time. So 4 entities on campus got together, the Peabody, the Art Gallery and the Center for British Arts, and a piece of the library system, the Beinecke Library. And we pooled our resources, because this is what was happening to everybody, of course, at the same time. And around that time also, there was a push to make digital assets you know, really readily discoverable and open access on campus. So there was a policy that Yale promulgated in 2011, actually in 2010, to provide open access. And so that actually birthed this thing here, which is called the Yale Digital Commons. So this was a campus digital partnership that initiated and went on from about 2009 to 2015 with shared resources, and it was administered by the then new department called the Yale Office of Digital Assets and Infrastructure, which was situated directly under the provost's office. So this is a new department. And so if we decode this diagram here a little bit, so we have the collection management systems, right? They're the things that hold digital assets, and I've got my emu icon there just as a stand-in for the various collection management systems on campus. Those digital assets flow into a dam with tape-based preservation as a backup there. The metadata records flow to an engine that's supporting a discovery portal, okay? External access and campus access to the materials. And then there's also with a local bespoke content delivery system, which we bolted to the dam itself, and that was to deliver suites of image derivatives. So that was actually necessary, of course, in order to you know, present the information appropriately on the World Wide Web. So that's a bit of the infrastructure there. Let's decode it a little further. So the dam that we actually used back at that time was from OpenText. It was called Media Manager. And so all of the different units in that collaboration began populating their assets and their metadata describing those assets into this particular system. We used basically library principles, the Bagot packaging protocol from the Library of Congress, was a major adopter, to push things over to the dam. And so basically a bag is, think of it as a container. You basically, you stick your asset in this bag, you put in some XML describing the asset, you put in a checksum, some other header information, and you send that off to a hot folder, and then the media manager, the asset management system, sits there, watches the hot folder, and ingests these things as it goes along. So the media manager has unique identifiers, of course. These are type 4 UUIDs. So, and they're nasty looking things, but machines love them. And so what we did is we crosswalked these back into EMU for API-based access. And so what we could do is we could actually call up the stuff in the dam directly from our collection management system, EMU. So that was great. Now, the media manager didn't provide any derivatives. So this is that bespoke thing called the content delivery system, which was built locally to provide those. And basically, it's an Amazon Web Services hosted and based environment in here that would take the master image from Media Manager, and it would be fed up in there, and a fixed set of derivatives would be made. These are basically JPEGs, and it's again for API-based access, and it incorporated the Media Manager UUID into that infrastructure, so you could actually call these things at the same time that you would call the master. The other bits and pieces of this architecture then, the digital preservation and the data warehousing components there, that was actually addressed at the time with Amazon Glacier. So we had tape backup for the assets and the other parts of this system. And this last part was the most interesting piece of the whole process. It was basically the experiment that we did. And so this is called the cross collections discovery here, and that's what I'll spend most of my time focusing on. So this is the first website that was stood up by the Digital Office of Digital Assets and Infrastructure. It combined those 4 units in here, and you could search for stuff from each of those units. And so this was basically a Solar engine with a viewfind delivery presentation layer strapped on top of it. And it still utilizes OEI, PMH, and resource sync as methods, XML-based methods for transferring metadata and for harvesting to get things over to that Solar index. Again, it's important to recognize that these are protocols in use by libraries. So here we are, museums, again, using library tools. And if you look at, for example, here's a query page where I've searched for Sappho in this system here, and I've got some results in there. There's faceted searching and that sort of thing, tiling as you typically see. But what's interesting here is that you search for Sappho, you end up getting the Greek poet from the art gallery and also from the Center of British Art, paintings and drawings, but you also get an extinct brachipod from the Peabody Museum because Camerotechia Sappho is a Latinized name. So here you have an example of a query that cuts across Yale units, very divergent units, but still gives you some results. So that's the basic principle behind this Yale Digital Commons and some of the infrastructure that was stood up to promote those principles. Here it is once again. So basically, collectively, we gave a damn. And some of the takeaways here was that this basically provided for it rationalized an institutional curatorial context for all the assets. There was a potential for novel cross-disciplinary engagement. And there was longevity, preservation, maintenance, programmatic access to materials. And it was economies of financial scale. We leveraged distributed computing knowledge, but probably one of the most interesting things, it demonstrated the capacity to crosswalk really diverse metadata models in use on campus. So for example, the Peabody there, we used Darwin Core to describe all of our material, with the exception, of course, of the anthropology and the non-biological disciplines that we have. But CDWA Light was in use at the gallery, Lido was in use at the British Art Center, and then Mark and Mods were in use at the Beinecke. So we actually developed a fairly basic primitive crosswalk of those systems in order to implement this whole infrastructure, and that's important later. Of course, we had a governance structure that was really smooth and everything. We all got along happily with the whole thing. Now this is a bit of a facetiousness. It was a really nice collaboration. So I like to segue up to the current time by talking about biologists basically impersonating archivists. And so this archivist here has the unenviable task of disentangling that very interesting looking manuscript right there. You know, we have specimens and artifacts in the museum, but you know, hey, we have lots of field notebooks, we have ledgers, we have correspondence, we have this kind of stuff too. And so why not? I mean, it's interesting enough to work with specimens, but the really cool thing is to open the field notebooks and connect them to the specimens, et cetera. So why not catalog these? So these are things, of course, that archivists have been working with for forever. And so we submitted several grants and were granted them from the CLIR, the Council on Library and Information Resources, to basically catalog our archives at the same time as we were cataloging our specimens and artifacts. This is done using the encoded archival description metadata standard, which was actually native to EMU at the time. So the way things are archivists organize things is by fonds, and then the series under the fonds, files and items under there. So this is a fairly straightforward classification scheme, if you will. And it's actually pretty familiar to what the biologists use. So here's Linnaeus. It looks just like Linnaeus classification scheme. And of course, it's a tree. And so that's great because biologists, we think in trees all the time. So it was a pretty easy sell to the collection staff to learn and start doing something completely different, cataloging the archives, because it was tree-based thinking. We're used to it. Speaking of think, the diagram there on the upper right, that's from Darwin's 1837 Transmutation of Species, and sort of the first diagram of an evolutionary tree. And you notice that he says, I think that things work this way. So it's a hypothesis. So remember that trees are hypotheses. So that actually is a nice segue because, so here's another tree. So what's the relationship between the museums on campus? Okay, well, there's the Peabody, the gallery, and the Center for British Art. Well, you might postulate that the gallery and the British Art Center share a common ancestor for the Natural History Museum, right? That makes some sense. They hold materials that are, you know, somewhat divergent from the natural history holdings. And you might hypothesize that the Yale Sterling Library, the Beinecke Rare Book Library, and the Manuscript and Archive Library, they're all libraries, so they're more closely related to one another than that other branch of the trees, right? Okay, well, that holds only so far. So if you take, these medieval coins that are in the anthropology department and also held at the gallery, so those are, I would argue, much more closely related to one another, certainly than a fish or a butterfly, for example. And so that's a little violation along the tree right there. Similarly, if you look at Romeo and Juliet and you discover that there's prints and diagrams held in the Beinecke Rare Book Library and also at the Center for British Art, that's also a sort of a parallelism or a divergence in the trees right there. And of course, we all hold maps. And so maybe that's a primitive characteristic. I don't know. It's hard to say. But basically, this tree thinking exposes what I consider a fundamental flaw in the Yale Digital Commons model. Basically, we're missing the library lineages here. Okay, we've got some in there, but we're missing the library lineages. And this is really core. And it's enlightened sort of the last 5 years, in particular, the last 1 or 2 years of work on campus. If you think about the Yale University Library, it's not a library. It's huge. It's got 15 million items. There are 15 separately named libraries, probably more than that. I'm just taking from their website. There's a wide variety of special collections units. Okay, those are kind of curious because they can hold all kinds of things. They don't just hold library materials. And the holdings of many academic departments scattered across campus. So this is a really big entity. And so in scale, if you were to put in what existed in the digital commons and draw it to scale, you see that the Peabody and the other 3 partners there, one of them being a library partner, don't come close to the same scale as what the entire library holds. Okay, so the issue is how do you redress that? So there were 3 things that came together that really helped address that. In 2016, Susan Gibbs, who's a university librarian, and she's still with us, she was promoted to the deputy provost for collections and scholarly communications. And this is great. It's a new deputy provost. And so she basically took over the reins from where the Office of Digital Assets and Infrastructure was. And she focused in the library, but she also was liaising directly with the museums and the galleries and other collections holdings at the same time. At the same time, the library was sort of upping its game. And so it brought to bear 2 very significant new digital systems, Preservica, which is a formal preservation system, and ArchivSpace to handle the vast array of archival material that was being cataloged in a whole different number of ways. So the infrastructure for the library got better at the same time. But the really key thing that happened in 2017 was that information technology services at Yale, so this is central IT at Yale, basically it's built out of 4 main pillars. It has this pillar concept. And so there's academic IT, research IT, clinical IT, and administrative IT there. This is a very well-funded entity at Yale. It holds a lot of power, a lot of people, and it really provides a backbone. But a new pillar was added in 2017 called the Cultural Heritage Pillar. And this is really key. And Susan Gibbs, in her role as vice provost, she was the chair of that committee. So what that meant is that suddenly the power of the Yale IT was available to cultural heritage. And so they could sponsor and represent major investments and projects, guidance and prioritization. Basically, we were playing with the big girls, if you will. And so this is when Chit was born, Cultural Heritage IT. And so I'll be speaking about Chit for the whole rest of the time. Sort of as icing on the cake in 2019, Susan was upgraded. She became the new vice provost, and she actually formally then gained responsibility in that vice provostial position for the preservation of cultural heritage at West Campus, new institute there, for the galleries and for the libraries and university press. So everything came under Susan's umbrella, and that really turbocharged things from that point on. So I'm going to speak to what's been happening really from about 2018, 2019 on from this point. So each of those pillars in information technology has a governance model that's sort of generalized and simple here. There's a steering committee, which invokes a program group down on the bottom left, and that's really where the action happens. And these things circulate in advisement to the service teams at ITS, right? So if the actual implementation of a lot of things are taken care of by the service teams. And then there's governance involved there, usually with directors of units and things like that. So that structure is really great. And we immediately, Susan started to populate that right away. So we collectively continued to really give a damn. So the steering committee was one of the first things there, and that spawned a large number of other committees. There's a CCD working group, an architecture group, bias and awareness committee, a rights working group, a wide variety of things. And so the priorities were identified right away, was to look at and swap out the DAM, which was aging at that point, the open text, to also swap out the content delivery system and to take a fresh look at cross-collections discovery. So the discovery group spawned a number of subgroups right there. There's about 50 Chit members in total. So it's a pretty wide collaboration with members from all across all the institutes on campus. Cheetah was born in there, a nice fast Cheetah in there. And basically Cheetah immediately looked at the DAM and the content delivery system because TripleF access to images was a hot topic and a pressing topic at that time. And of course, one of the most important things in all this with such a elaborate collaboration is you have to have a really competent project manager. So Sarah Prown was hired. She used to actually work for the Yale library system. So she had context knowledge. She's fabulous. She's also plays all kinds of different instruments. And so is basically sings and sort of orchestrates the whole thing. So basically this is the old YDC2. You stick the targeting computer on it and you build a new model. Of course, what do we do, right? Okay, so let's fill this model up and take a quick look at it. All right, so there's pieces that we're familiar with already. Over on the upper left is the units themselves with their collection management systems. You see the solar engine in there, that's still extant, the metadata and discovery piece, the little plant icon that's kind of squished there, that's the content delivery, and then the website, the CCD, the cross collections discovery. So those are bits and pieces that you recognize hopefully from earlier in the talk. And so what we do and what everybody does is pass data through basically an ingest workflow that's specified by each unit. And it lands in a thing called Traffic Manager. So this is brand new. So this is Colorado. So I figure I can get away with using a South Park character in here to represent the Traffic Manager. The Traffic Manager is actually absolutely key to the whole kit and caboodle. So Traffic Manager sits right in the middle there and directs all the traffic amongst all these various systems. It's affectionately known as TMAN. So you can think of it basically as a dynamic stateful knowledge of a digital asset in the Yale computing ecosystem. It's basically current. So it's a lightweight AWS-based SQL instance in there. And it's really, at its core, it's only two tables. It holds critical unit identifiers, critical metadata elements, various process-oriented flagging, and then status reporting and messaging. So if you want to update an asset someplace in the system, you tell TMAN go do it. If you want to delete one, you want to ingest to it, basically you tell TMAN to do your bidding for you, okay? So with that infrastructure in place, we immediately upgraded the two pieces of this core central column. So we swapped out OpenText for Netex as a new professional DAM. And we also capitalized on Preservica, which the library had just put forth for all of its assets. And so that became the preservation repository for all the museum's assets as well. So that's a link across campus right there. Netex itself is a much more modern interface. It's a pretty easy to use system. If there's time, I'll demonstrate it briefly. But basically, we underwent a migration, migrated close to 1 million assets from across those units from the Media Manager over into Netex. And Netex is a very sort of user-friendly, image-oriented thing here. So you can see I've entered a query there for George Peabody, our founder and benefactor. And so I get some things that relate to his collecting activity, but also there's a picture of George Peabody being taken down from the lobby during the renovation right here. So one of the hopes here is that this dam actually will serve not just the collections components of the Peabody, but it'll also serve some of the public facing units in the Peabody as well. And so we're gradually moving folks into the use of Netex who are not collections oriented. Okay. The next thing that we looked at, and actually this is active right now, literally active right now. We are literally going live this week in CDS2, at least for the Peabody Museum in TripleF. So what this is for those of you familiar with TripleF, this is a standard context that came out of the, basically out of the art world for comparing images from diverse sources, especially sources in different repositories across the world. So this is a much more modern scalable interface in here. And so we operate here. So we're using activity streams rather than resource sync or some of these older methodologies to actually feed metadata from the various campus units into what are called manifests. And the manifests sit behind TripleF, and the manifest describes, how to present that asset in context. So it's a new twist in here for us learning the activity streams. That's the technical piece that's in there. Okay, so the only thing left in here is for the targeting computer to take a look at the cross collections discovery piece, right? So CDS2, like I said yesterday, I heard that all of our assets were primed and done for CDS2. So hopefully I'll show you some of those today. So the Chit collaboration started, so that was Cheetah work, basically, for those upgrades there. The Chit metadata working group started looking pretty closely at the campus-wide picture. And so we took did basically an environmental scan for the various schemas in use all across campus and looking for a crosswalk. It was a gap analysis. So we looked at all the various collecting units, no matter what their size were on campus, the number of records they had. We identified the schema and whether they had an active endpoint right now, whether they were distributing things, to either internally or externally. And this is once again trying to build on that tree. What we found was that the 5 previous metadata schemas that I mentioned before, back in the original Digital Commons, those are pretty much the major use cases on campus, except that Lido has supplanted CDWA in one of the galleries. The archival collections are not well represented amongst the things with an endpoint. And that's EAD is the major metadata model that needs to be brought in there. And most of the library units actually had an alternative to this Digital Commons that powered discovery. And that's a thing called Find It. It's also a Solr-like index with a mods-like schema behind it. Okay, so what collecting units and technologies were missing? So the metadata working group then analyzed the difference between the Digital Commons Solr index, which had 197 elements, and the library Solr index, which had 223. So they're very similar to one another. And it turns out that 82 of those elements, the library elements, were expressed in this Find It federated search. And in fact, there were 46 of those elements common to the Digital Commons and the library Solr index. And so, and those are the majority of the elements shared among the museums and those shared among the various library units. So this is actually very promising because it shows that basically our metadata is not that divergent as what we thought. We could potentially work on bringing this all together. So the metadata working group then immediately started to assemble sort of a grand schema. So we pulled together several of the schemas, made one. We tried to identify the same fields, crosswalk them, categorize and group them by context. In other words, build entities. Those are in the blue. And then, so that would lead to analyzing and harmonizing comparable metadata in there, which is reconciliation. So we're basically, this is active work right now. We're looking to bring technical solutions for reconciling these schemas into the Chit framework. So, and I like to say that these things are essentially the Loxodonta africana in the room, or the elephant in the room if you don't do Latinized names, because if you don't solve the question of what do we call things and do we map them correctly, then you're basically screwed. So this is a really fundamental part of the work of Chit, and it involves conceptual modeling and visioning. In fact, quite a bit of it. So after the initial attack on the schema there, we really needed to kind of take that schema to the next level and think about the next level, the architecture. So we actually engaged Design for Concept, a group to do a visioning work on campus. And so this is a vision for what the cross collections discovery could be. This is a workshop held in late 2019. Spanned 2 days. There were 15 departments involved and more than 30 participants, and they were selected to represent a breadth of all the types of patrons and workers amongst the collecting units on campus. So what did we do? It was actually loads of fun. So we brainstormed. We did a lot of scribbling. We wrote goals and 26 mission statements, really divergent. And this is really kind of interesting. We proto-wireframed. I mean, there's some crazy, interesting ideas that came out of this. So, down in the bottom left there, you searched for horse. Visually similar images are this. Or up in the upper left, there are 4 mobile librarians in your area. We are currently connecting you to. So there are a lot of really interesting, perhaps controversial topics raised in this visioning exercise. But basically throughout the whole thing, we were dreaming about linked data the whole time and trying to wrap our heads around what would be the next step in the schema work that was necessary. We generated more than 200 requirements for a potential cross-collections discovery system. So the system shall provide a single point of entry for all collections at Yale. It shall search simultaneously across all repositories, da, 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 da. And so these were grouped into a wide array of different requirements. And then we started prioritizing these, deciding what would be in and out during a first phase implementation, et cetera. So this is a very, very active work right now. Sarah organized all of this. This is a little facetious, but her skill set is actually critically important to this whole operation. So she sits and manages all the various groups that are led by other folks, but she's the one who's basically organizing all this stuff together. So the cross collections discovery needed a new name. That's a kind of a mouthful, right? So what do? Well, we actually stole from Yale. We chose Lux to be it. So basically, I guess the idea here is that it's light. So we're shining light. We're not claiming that we're holding the truth. We're just shining light on the assets. So Lux was born. And so this is the chart right now for the current 3 fiscal years. Yale's fiscal years run from June to June for fiscal year 2021, which is where we are, and 2022, and what's going on here. So there's a lot of activity going on in the various bits and pieces in here. So, and of course, then COVID hit, and so COVID Chit became the norm, and the committees there, we started Zooming like crazy, and this is actually kind of good. It worked really well. We had very large numbers of meetings. All of the different committees were represented in various ways on the Zoom conferences in here. And so one thing that came right out of this was that we needed some funding to work on the metadata reconciliation and harmonization, because that was sort of beyond the wheelhouse of all of us, even though collectively we could kind of handle that. So we submitted a grant to the Mellon Foundation. It was funded in 2020 for a 3-year grant to work on just that process. And this fellow right here in the middle, some of you probably know him, that's Rob Sanderson. So we were very, very, very fortunate to be able to lure Rob Sanderson away from the Getty Trust in Los Angeles, where he was their semantic architect. And he came, and his official title is that he's directing this Mellon-funded project for enhancing the description and discovery of the cultural heritage collections, concentrating on harmonization. But in practice, he's an integral piece of Chit instantly. And this is actually a Chit project. That Mellon Foundation is another project that Chit is doing. Okay, so what have we done most recently? Well, we just recently stood up a prototype, basically a proof of concept of the Lux Yale Cross Collections Discovery Platform. It's Blacklight on solar, so it's a relatively similar known technology. We're able to load about 15 million records. That's representing what was available from the library and all the other units. We used a fairly straightforward JSON lines protocol, build a bunch of external files, load them externally, and then suck them in using ingest procedures. The good thing here is we were able to demonstrate that this works at scale. So it takes about maybe 1, maybe 2 days when you account for individual units having to marshal their next round of data. It takes about 2 days to do a full rebuild. So we knew we were operating more or less at about the right scale. It's not something that was taking us a month to rebuild the whole creature. And of course, deltas would go vastly faster than that, but we could rebuild the whole thing if we wanted to. And so we did so. We went through a bunch of iterations. We basically knocked it down, rebuilt it, knocked it down, rebuilt it. Each time as we were iterating those schemas along a little further towards light and truth, we would rebuild this proof of concept. And so indeed, that Lux schema has greatly changed. It went through 9 formal iterations. It's now currently at 252 fields. They're organized in 18 groups, and they're arranged for entity and metadata refinement. So this isn't a flat, well, it is a flat spreadsheet, right? But it's not really a flat spreadsheet anymore. We're trying to do something in a little bit more comprehensive. So the 18 groups are identified here. And so they're essentially common entities, event-related sorts of things that are reflected in each of the different collecting units. So everybody has agents, their places, their dates, their subjects, languages, rights, and citations. All of these things operate within each of the units, and the goal here is to try to match up all of these entities in a more fruitful way. So here is, and so the good thing about having the proof of concept is that we could dump the data directly out of all the contributing units and then take a look at it and try and work on the harmonization. So this is live POC data dumped out into a Google Doc here. And so the reconciliation here is being done by 9 event types. So this is, here we have the place roles and the date roles, which is just 2 examples out of all the holdings here. And so you see it's organized into, the places and dates, is the sponsoring and commissioning of works, the production and design of objects, so writing of text, composition of music. Those are kind of similar sort of event-driven things, publishing and distributing, performance and interpretation, discovery or collection of an object or artifact or specimen, etc. So these are sort of the event-based things that we're layering on top here. And so here, for example, is a little bit more complicated one. This is the agent role. So you've got donors, collectors, performers, artists, makers, printers, carvers, you name it, all over the map. And so what we're doing actually is identifying where there's commonality amongst all the units. And in particular, most of these things are represented, for example, in the linked open data world. So you can find identifiers from, say, the Library of Congress or, the Getty, vocabularies to associate URIs with these. And so we don't necessarily need to represent, it's all text string based right now. What we really want to do is represent it by external identifiers and then start talking about the external identifiers being, working with those and bringing a small sets of those back into the collection management systems as possible. So this is a little bit, probably a little bit more familiar to those of you who work in the sort of in the linked open data world. This is sort of the high level Lux modeling. This is Rob Sanderson's metadata working groups. This is his OmniGraphal. It's taken basically after linked art, which is a project that he's intimately involved in. And it shows these relationships a little bit more graphically. So you have a physical object there, right, which is what you hold at the far left. And it may be depicted in a visual work, in a textual work. All of these things have places and actors. They show concepts. They're created by a creation event in the middle there, which was carried out by an actor, as an artist or a collector in a particular time span at a particular place, etc. So the idea is to try and represent in the cross collections, the new cross collections discovery in Lux, these aspects. And so not all of this can be done easily using technology that we had been using. So we need some new technology on there. And that's the most active part of the Chit collaboration right now. And you see some of the target vocabularies and identifiers down at the bottom there. So you've got the art and architecture thesaurus, thesaurus of geographic names, ULAN and stuff from Getty. You've got the OCLC, you've got Library of Congress, and Wikidata. So it's sort of standard locations of identifier-based materials. And so also one of the groups that was spawned was a UX usability working group. So we've got this prototype, and as we work towards implementation of Lux, these folks were looking at, well, how do we actually design this interface? And so here, for example, are some of the wireframes that they've been working on just in the last couple of weeks. So here's they're looking at the search box, how might you present the results and the faceting with a current record count of almost 16 million. Here's a wireframe that might show a sort of, an image view on this. This is all really active work that's being done here. For example, then they're working on draft icons. So we've got a sort of a grand classificatory scheme that describes what's in here, and we're trying to develop icons that are good for pathfinding and that are easy to perhaps understand the distinctions between these various things. So whereas it may be database, a data set, those things may be sort of an abstraction to a casual user, that means something to the computer scientists, but how do we make this approachable at all levels? And so the architecture itself, this new architecture that's being put in place. So we need a couple of things. We need a document store, which we already have that in Solr, a text index, but we also really need a graph index to reflect these relationships and the entities and things like that. So this is extremely active right now. We're exploring existing vending solutions and also particularly whether it's cost effective to integrate some of these standalone best of breed products into a more bespoke architecture. So this is option one, a multi-system. So you've got basically in the middle of there, you've got some kind of a platform providing the text index, another platform providing the graph index, and another one that should back end there where there's pre-computed visualizations of various sorts is what we're envisioning on the back end. And those things all interact with the record store, et cetera, to show something out on the right, which is LUX. But there's another way of looking at this, which is essentially, all of these functionalities may be held in one particular system. It's a multi-model database. And so basically that's unicorn hunting. So that's what the Cheetah group is doing right now. They're running rapidly fast to see if they can find a unicorn. If they can find a unicorn, catch it. If not, then we'll roll with option 2. And so I can't really speak to the exact details of what we're doing in that regard with vendors, but this is basically the principle that we're following right now. And we're anticipating the LUX build. The actual build will start in June of this year, and it will be delivered sometime during fiscal 2022, probably targeting the spring of 2022. So we're right now in the process of doing gating process with the information technology, vetting, are these platforms, suitable, do we have the appropriate resources for them, et cetera. And we're doing all of this not really last minute, but this hot last step planning for what this infrastructure really might look like. And we don't have an answer, right? We're still chasing this magic unicorn, or at least that process. So the next couple of months, we'll kind of settle down what Yale is actually going to do as the sort of the engine or engines behind this new instance that we have or hope to have. And so with that, that is actually the end of my formal talk there, and put up the acknowledgements and credits here and come out of the PowerPoint. So I have some of these systems, won't take long. Pat, what do you think? Do you think we have a fair number of questions to answer, a quick demo, or what would be the best thing?
I think why don't you go ahead and demo something, because I'm sure people would love to see this in action, and then we can go look at the chat.
Sure. Okay, so I'll start in, this is our, those of you who use email are familiar with this. So I'm going to go into email and I'm going to call up a record. In this case, I'm going to call up a moth record here. What's my problem, of course, is that I can't type. So there we go. That's better. So here's a record in our catalog module. I'm in as a super user, so there's lots of screens and things available to me here. And here's some basic metadata about it. It's a moth collected in Florida. And there are a couple of images affiliated with it here. And so if I take a look at those images over in the multimedia module in EMU, here we are. Here's one image right there, and here's the other image. So there's a dorsal and a ventral. But you'll notice that if I go to resources here, I have a couple of options here. Display the largest JPEG from the Yale CDS. So that's the content delivery system. If I click that, that's actually, so there's that old existing infrastructure from the content delivery system. I'm taking a peek at the asset right there, but I don't know it. From my perspective, I'm just sitting in EMU doing my thing. And if I want to get the master asset from Preservica, there's a connection directly to it there. So now I'm actually looking at the master right here. So I'm just a click away from these resources within my collection management system. Furthermore, if I go back to the catalog record here, and this is the stuff that's just been implemented over the last day, if I go here into resources, I can display the largest sort of primary derivative for it from the old content delivery system, but I can call that image up in the CDS too. So here we are in TripleF, and so I can see both the dorsal and the ventral of this critter right here. And there's metadata affiliated with right here. And I can actually click directly over to where that specimen lives in our online collections catalog, which is right here. So essentially all of these systems are sort of seamlessly integrated with one another. And this would also be true for an individual sitting at, for example, the British Art Center or wherever. They implement completely different methodologies really to connect to these infrastructures, but that's really how it's done. And so one of the things about so here I talked about a manifest. It's basically a JSON representation of the data in here. So if I just take that manifest right here, I can add things in here. So if I add that resource in TripleF, right? Now I've got 2 specimens, and I could have that specimen could have lived in the British Museum over in London, for all I know, right, if they had TripleF enabled assets. And so now I can actually do side-by-side comparisons of these things here in this different context. So that's really sort of the wonder and greatness of TripleF, which isn't widely used in the museum world, right? Excuse me, in the natural history museum world right now. It's much more broadly used in art institutions. So let me just go back to the catalog module just briefly one more time. Let me do a new query and let me type, look for our holotype of Apatosaurus ajax. And so there are many things with the 001680. So let's do VP because I happen to know it's a vertebrate paleontology specimen. We'll get it there. Here we go. So that's it right there. And if you take a look at this critter, it has quite a few multimedia affiliated with it. And so if you look at its CDS2 representation, you see you've got all manners of images here, but you get the idea. You have access to the entire suite and you can rearrange these as you want. You can put the images on the bottom, et cetera, you know, and click through them as if it were a gallery. So this really greatly expands the access to the asset-based material in here. The only other thing I want to show you briefly is Netex. So I'll log in. And here we are in Netex. So for example, let's see what we have from Colorado, just out of curiosity. That would be a sensible query to do, wouldn't it, Larry? Oh, there's lots of things. So, well, let's look at them here. Oh, they look like lots and lots of brachiopods. Only a brachiopoid lover could see that. So you see there's metadata that comes directly from the cataloging system that's reflected over in here, but I can look at it in different ways. Let's do Boulder, Colorado, see what we get. That's probably better. Hey, that looks a little more interesting. Oh, so, okay, so I like that one. That's a plant specimen. It's kind of neat. Look, there's some bird eggs and there's a butterfly. That's kind of neat. Cool. Oh, so I've selected 3 things. Why don't I collect them? I'll build a collection here. Okay, so I'll make a new name. So let's call it Cindy and Pat. Okay, and we'll save my little collection right there for them. And so if I look at collections, I have my Cindy and Pat collection right here. There it is. That's kind of cool. So I could actually share that if I chose to. Could create a link. So I'll let it expire tomorrow. And what do I want to do with this? Well, okay, I don't want to give them the original assets. I'll give them the thumbnails just because they want to see what's going on. I'll give them a PDF. I can make it 3x3 attributes, whatever. I'll do that. And I'll basically pick just the basics attribute set that I've held myself in Netex here, and I'll create a link. And so I'll copy the link to the clipboard. I'll get into email and I'll send it off to Pat and to Cindy in thanks for their stuff for helping out with this. And they will presumably see within a minute or two, they will actually get a little asset package with those assets in there. And if I show you myself what it looks like, here it is. That's what they should be receiving. So I've got a PDF right here, which is sort of a context sheet, right, showing in the nature of the assets here, and I can control what those are in here. And then the actual assets themselves, which I sent them. So this is a really great little delivery package methodology here. So that's Netex in an instant. Okay.
Excellent, Larry. Thank you so much. I know that we're all super appreciative of the sociological, the technological aspects of the work that you presented to us. I don't see a question in the chat, but so let me ask you one while we're waiting. I know we just have a couple minutes here. Larry, how were potential users represented in your conversation? So it felt like this felt like a little bit like build it and they will search it or something like that. How did you talk to potential faculty, students, staff
Yep.
about